Okay, before I go and create a VM, it's important to have a look at our storage account because this is where the VHD will actually be created. We saw this in the last webinar. We talked about geo-replication. So if we click into this storage account that I've created, you can see I have geo-replication enabled. And I've created a container called VHDs for my VHD files. So when we create our VM, we'll be able to leverage the SLA around our storage accounts, as well as get that geo-replication for resilience. So let's click back out into virtual machines, click new, and click from gallery. And here we can see that the gallery of images that we can use to create our VM. Everything from Windows Server, SharePoint, SQL Server, Oracle, and different flavors of Linux. I'm going to create a Windows Server 2012 or 2 image. I can give it a name. I can decide on the number of cores and the memory that I'd like, and give it a username and password. We talked previously about the concept of a cloud service. This allows me to group servers together to create a single public endpoint and create load balancing. We'll talk about that in a few minutes. I can connect this VM to a particular virtual network, or I can decide which region that it should be in. We'll talk about the virtual networks again later. And here I can select my storage account. So I can select my demo VM's storage account to create that VM with geo-replication. And finally, I can select or create a new availability set. We'll talk about this in a couple of minutes. And this is key when it comes to creating a highly available solution. The other approach we have for creating a VM is to use an image that we've created ourselves. If we click into images here, you can see that I have a number of images that I've created. So these are VHD files that I've created locally on premise, configured, run sysprep, and uploaded to Azure. So I can very quickly create a new image or a new VM from gallery, but this time select my images. You can see I have an image for a web server in the EU and a web server in the US, as well as a SharePoint-based image. One question I'm often asked is, how do I control my environment within Azure? How do I automate the process of creating VMs and shutting them down? This is particularly important in a dev and test environment where you may not want VMs running 24/7. Or there may be scenarios where spinning up new VMs is not enough, that there is some configuration required before these VMs are usable. A great example of this actually is SharePoint. If we want to scale a SharePoint farm, we must add a new server and then run the SharePoint configuration tool to join that server to the farm. We must also then ensure the server is part of the load balance set within Azure so that it can start to respond to requests. In these scenarios, PowerShell provides a powerful solution to automate these tasks. Using PowerShell, we can spin up VMs, run scripts on VMs, configure networks, or even upload and download VMs. Let's take a look at another demo. This time I have a complete SharePoint farm, but I'd like to add a new web front-end server to help deal with increased traffic. I also need to ensure that the farm is highly available. You can see here my list of VMs. So my SharePoint farm is composed of a couple of web servers, a domain controller, a database server, and an application server. I also have an admin server that I use to connect a remote desktop into that farm to configure the different servers within the farm. Now, we talked about cloud services before, but essentially my cloud service for my SharePoint farm is that public endpoint. It's how people access my SharePoint farm. So if you see here, we have a URL, and if I click that, it will bring you into my SharePoint farm. This is a Contoso electronic superstore. So Contoso are using SharePoint internally for their intranets. They're using extranets, but they're also using it to publish content to their website, which is an online retail shopping cart type website. If I click into my cloud service and have a look at the instances within that, I can see that I have two web servers, ConWeb and ConWeb02. A couple of columns here that are really important from the point of view of availability. It's the update domain and fault domain. If we think about how the infrastructure is managed within the data center, we have the concept of a fault domain, and anything within that fault domain has the potential to go down if there is a fault, but individual fault domains are isolated from each other. We also have the concept of an update domain. This is where a physical piece of hardware which runs your VM may need to be updated or patched. So the Hyper-V Windows server on that physical host may need to be patched. And for this reason, it's really important that when we want to load balance, for example, web servers, that we have at least two, and that they all work within their own, within a single availability set. These availability sets ensure that the servers are in different update domains and different fault domains. If we click on the Scale tab, for example, you'll see that we have an availability set called ConWeb AS, and we have two instances within that. And that ensures that at worst case scenario, at least one server will be running at any one time within that availability set out of the two that I've got in there. It's also important to realize from an SLA perspective, to achieve the SLA or greater, which is 99.95, you must have your servers, at least two servers running within an availability set. Okay, I want to add a new web server into my load balanced web servers. So right now I've got two. I want to add in a third. Now SharePoint's unusual in that I can just add a new server using the new VM option. But of course with SharePoint it needs to be configured once the server is up. So there needs to be extra configuration done. So I'm going to remote desktop to my administration server. And I'm going to show you a PowerShell script that I've created. And this PowerShell script will allow me to create a new web server, add it to the web server load balance set, add it to the availability set of my web front end servers, and also run the SharePoint configuration tool all within one script. So we can see here that I'm creating a new Azure VM configuration. I'm defining my availability set. I'm defining the image that I'd like to use. And I'm even defining the endpoint. So I want it to be available on port 80, but the local port is 3456. That's how it's been configured within the farm. And then down here we have we're invoking commands on the server once it's created. I'm just going to run that script and let it run. From a scaling point of view, we can configure auto scaling. We showed this in our first webinar with websites, but we can also do this with infrastructure services as well. So we can see my availability set now has 3 instances. And once that server is deployed, I can look at setting up scaling based on CPU, exactly as we did for our websites. So we can define CPU metrics that control how many servers should be running at any one time. And that allows us to scale out or to scale back in when demand reduces. I've included a slide there with some links to some SharePoint resources. If you are interested in deploying SharePoint farms, those links could be very useful for you. So deploying apps and VMs to the public cloud is great when you want to give the public access, but what if you want to restrict access to your corporate domain or to a specific group of people? Virtual networks allow you to create a logical, isolated section of Windows Azure and treat it like your own network. You can customize the network configuration for a virtual network. You can create subnets, assign private IP addresses, and bring your own DNS server if you wish. Within a virtual network, for example, you can create a public-facing subnet for your web servers that has access to the internet. Place your back-end systems such as databases or application servers in a private-facing subnet with no internet access. So there are a few benefits of using a virtual network. You can persist your own IP addresses for virtual machines. That means when you're deploying SharePoint in a Windows Azure or enabling Active Directory in virtual machines, the persistent IP address you need is there and available. You can build services with common tiers where all apps, whether in the cloud or on-premise, use the same Active Directory, use the same database tier, or are managed by the same System Center Operations Manager, since they are all in the same network and communicate directly to each other. You can build composite multi-tier applications that take advantage of Windows Azure Web and Worker roles, which is our platform as a service model, as well as virtual machines, which is our infrastructure as a service model. And using virtual network will enable those instances to talk to each other. Think of a web application deployed to PaaS and using an Oracle or MongoDB deployed to infrastructure services. You can also point all virtual machines to a DNS server on-premise or a DNS server running in a virtual network. This capability enables you to use your own domain controllers in Windows Azure to enable single sign-on for your applications. In order to connect your on-premise network to Azure, you use a VPN, which encrypts and controls the traffic flow between the on-premise network and Azure. There are two types of VPN within Azure, a point-to-site and a site-to-site. Point-to-site allows you to set up a VPN between one or more client computers and the Azure virtual network. Setting it up is very simple and just requires a certificate for encryption and a small download to set up the VPN on the client computer. Once that's done, you can connect to the virtual network on Azure. This is particularly useful if you don't want to join your on-premise and virtual networks, but you want to allow certain client devices access to manage your Azure resources. The site-to-site VPN allows you to connect a VPN device or software VPN via Windows Server, routing and remote access service to your Azure virtual network. This will allow resources on your on-premise network to communicate directly with resources on your Azure virtual network, providing the basis for many hybrid cloud workloads. There's a list of supported VPN devices and prerequisites for generic devices, and I've included a URL in that slide. So let's take a quick look at how I might set up a point-to-site VPN. So going back to my Azure dashboard, I'm going to scroll down and have a look at my networks. So whenever I configure virtual machines within Azure, I always configure them within a virtual network. This just gives me better control over the IP addresses of the machines, as well as allowing me to connect it to my on-premise network if I desire. So I've created a network for my Console SharePoint farm. And if we look at the list of servers in here, we can see the defined local IP addresses. I've got a domain controller, my database, and they're all on different subnets. You can see all my web servers are on the same subnet. And I've created a gateway, an internet gateway, which will allow me to connect securely my VPN to the Azure virtual network. So once I have that gateway set up, I can simply download a client VPN package to my client computer and connect the VPN. So I'm going to switch over to a local server that I have. And in the command prompt, I'm going to try and ping that domain controller that we saw. And of course, because this is an on-premise server, it has no knowledge of that IP address and will not give me a response. So I'm going to simply run my VPN configuration tool, which I downloaded from the Azure dashboard. As well as that, I just have to have the certificates local, and that's what will set up the handshake between this machine and Windows Azure Virtual Network. So once I've installed that, I can see now that I have a virtual or VPN connection within my connections list. So let's connect to that. So now this local on-premise server is connected to my Azure virtual network, and I can get a reply from that domain controller. That allows me now to connect this machine to that domain, maybe set this machine up as a secondary domain controller. I can even remote desktop to that server now and log in using my corporate credentials. I'm not sure how well you'll see a remote desktop session within a remote desktop session over a link, but that's how it works. Just wanted to let you know about a new feature that has found its way into the PowerShell scripts, but it's not yet available within the management portal, and that's the ability to control access to specific endpoints within Azure. So when you create a VM in Azure, you can define endpoints, and up until this release, those endpoints were public, so you could only either open or close a port on a VM. With ACLs, you can now open a port and restrict access to a specific IP address or range. I've included a link with a full specification on how you can set these ACLs up. So to summarize, you can use Azure to create VMs, whether Windows or Linux. You can create virtual cloud networks to control access to your VMs, or to connect your VMs to your corporate network. Finally, just a reminder that you can manage all of your VMs using System Center 2012, and soon you'll be able to use Azure as a DR solution for your on-premise VMs too. So again, as before, we've got a free trial. Link is included in there. If you've got an MSDN subscription, you do have some usage. So have a look, or if you don't, talk to your account manager. The training kit links and the Virtual Academy links are in there again for you to have a look at those. Some great video content and presentations and demo labs, etc. And again, for any updates to Azure, there have been a couple in the last week, you can follow my blog.